Hi everyone, I'm excited to bring you our second professional development edition of Digging Deeper. This one is focused on 3-act math tasks and our math practice standards. Our first session was focused on number talks and growth mindset, and hopefully you've had a chance to engage in a few of those and continue to build growth mindset into what you do on a daily basis. 3-act math tasks are they're engaging. They're awesome. I've enjoyed them in my classroom. I know our students have as well, so I'm excited to bring this resource to you. If it is something you are already doing, if it's something you're aware of, great. Hopefully you can build on it based on what I shared today. If it's not, my hope is I've opened up a door and I've been able to arm you with just one more resource that you can use as you plan and as you look to engage our students. 3-act math tasks are broken up into 3 parts, and each part has a little bit of a different purpose. Act 1 is for engaging in curiosity, and this is the part where students are given information. They are opened up to the problem. It is the part where students start to notice some certain things, and we ask them to wonder about what's going on. And they'll raise their hand and they'll ask questions of what's going on there? Why are you showing this to me? Why is this video on the screen? So it sparks a little bit of engagement, and students start to pop up in their seat as it's not just a worksheet that's in front of them. It's typically visual, and it's a video or it's a picture. So once Act 1 is provided, Act 1 presents students with a question and a visual. Act 2, now students are given more information and they're asked to work through the problem. It's solution-based. Students have a chance to take what they know from Act 1, get a little bit more information in Act 2, and solve the problem. Act 2 is the body of the 3-act task. It's where students are doing the work and use the teacher monitoring what they're doing and just encouraging them to take what they know, take what they're given, and apply it. Act 3 is the solution. It's the discussion. It's where the answers is shared, and students have a chance to defend their thinking and talk about why someone solved it a different way. Act 3 promotes a lot of conversation and is collaboration based, and oftentimes students have a chance to celebrate, and the teacher has a chance to highlight great thinking or thinking that maybe wasn't correct but still useful for learning purposes. So each act is a little bit different, and as you can see and here, Act 1, a little bit of information, Act 2, a little bit more information, and Act 3, all of the information. So it is a real world problem, the same thing we experience as adults. We're given a little bit of information here or there, but we have to problem solve through how to figure it out. 3-act tasks are powerful. It's not punishment. It's sometimes kids are doing math problems and they think this is awful. I hate just working through these problems 1 through 30. A 3-act math task can take 10 to 15 minutes, 20 minutes if you feel like you need enough time for it there. And there's a lot of powerful thinking going on in the 3-act task. The value of a task is it's engaging. The context of it is engaging. It promotes mathematical understanding. So you're still doing math concepts. It just looks a little bit different, and it feels different to students too, so you get more buy-in. It reduces the literacy demand. There's not a ton of reading. We have students that are strong in math, but not so strong in reading. This is the problem for them. Oftentimes students love 3-act tasks and want to just do 3-act math tasks, which we know there's a purpose and a place for everything, but that idea of reducing some of the reading is comforting for some students. It adds engagement, it adds wonder. All students can be engaged in this. Item 4 says there's low barriers for entrance. Essentially what that means is students have the opportunity to join in on the problem. It's not too high, it's not too low. Everyone can apply their experiences to this problem. And what's great about it is oftentimes students connect and they're familiar with the video or what's going on, or they say, oh, I've done something like that before, and then they take those experiences and they apply it into math. And it's just great because all students can participate. 3-act tasks provide an opportunity for estimation. Estimation is the beginning portion of this. The same way good readers make predictions, good mathematicians estimate. And they take what they know and they say, well, I think it's going to be about this. And again, they're just given a little bit of information from the get-go, but they take that information and they can start to make some estimations. And now this idea of mental math and estimation comes to life because it's being taught. Their students are being exposed to it in the problem. It's a chance for students to engage in reflection, teachers to engage in reflection with them, model some thinking here and there, and really reflection is so important, and we can develop it in our youngest of learners all the way up to our 12th grade students. Encourage multiple approaches and honor diversity. This is important. We all solve problems different ways. In life, we solve problems different ways. In the classroom, we solve. So we can honor that and we can reinforce it. And the 3-act task is just a way to do that. Students have a chance to build this understanding of math concepts and the way they interact with each other. In math, oftentimes we teach concepts in isolation, which has value, but also we have to understand and provide our students with experiences where they're using several concepts for one problem. That's what's great about the 3-act task. Students take a little bit here, a little bit there from Unit 1, from Unit 3, from Unit 5, and they use those concepts to solve a real world problem. And it's a shift. It's a shift that math is way more than just something you do in the classroom. Math is about solving problems and it's about thinking. Math is about stretching your brain into this point where you're comfortable thinking and solving problems. We shouldn't just teach how to solve an algorithm, or we shouldn't just teach what an algorithm is. I think we need to be teaching thinking and how to think through problems, and the 3-act task provides an opportunity for teachers to do that. Brief rundown. Act 1 is visual. It's a photo or a video. It's a hook, essentially. It sparks curiosity, provides an opportunity for students to ask some questions and wonder about what's going on. Good math teachers engage their students in this idea of notice and wonder talk. And notice and wonder talk is just a chance for the teacher to talk about what students are thinking when they're given a problem, what they're wondering about when they're given a problem. It's limited reading, which is really important for students and teachers because you can just focus on the math and you don't have to focus on comprehension of a problem. And students are forced to define what's going to happen and define what they're being asked to do. And I really think that part is important because it reinforces the fact that when we're given a problem, there is a question to it. It's not just words. It's a problem that we're trying to solve, no matter how we can solve it. And again, in real life as adults, as teachers, principals, nurses, we are all given problems on a daily basis that we have to solve. And there's no algorithm for it. So right now what we're doing in our young classrooms is we're teaching kids how to just think, and that's got to be the goal. Act 2 is about estimation, is about finding are answers reasonable, and what information am I given to help determine what the solution would be. This is the chance where students can work through the problem however they want. They have information from Act 1. They have a little bit more information from Act 2. They take that however they want. They piece it together, and then they start to solve. And it's really fun to see the wheels turning. And some students, the light bulb clicks on, and they say, oh, wait a second, I forgot about this or that. And they start to show their thinking on their paper in preparation for Act 3, which is the reveal. It's the chance for students to share out their thinking, defend their work, critique the reasoning of others, and discussions are had, and they're needed. And teachers can share out strategies, students can share out strategies, and it's another opportunity to celebrate success. And it's an opportunity to celebrate this idea of a growth mindset. And even if you didn't get it, you probably came close. Or if you didn't come close, at least you were able to piece together and stretch your brain a little bit. So no matter what happens at the end of a 3-act task, I think there's reason to be to celebrate all student success. Here's just a quick visual, and you're going to get this on a Google slide when I show this out, but this is just from a teacher, and I thought it was really neat because it was visual, but it also provided a good rundown, a brief rundown of what we're looking for in each act. Act 1, setup. Act 2 is the solve, and Act 3 is the reveal. Just some examples of 3-act tasks I found online. It all adds up, is about adding and subtracting money. It's a grade 1. A fruit nut bar I love. It's a multiplication division task within 100 for grade 3 students, and the final lap is comparing and ordering decimals, grade 5. I'm going to click on It All Adds Up just so you can see it. Brings us up to our website. You don't have to create this. There's all kinds of resources on 3-act tasks, but Act 1 is just a video, and there's questions down here, and it says, what do you notice, what do you wonder? And then it says, what coins did he put in the bank? And really that's the question. The question is, you have to figure out what coins go into the bank. As the video is going on, the teacher is saying, what do you notice about this? What do you wonder? Why is he putting the coins in the bank? What coins are going in the bank? Now what happens when we clear it out and you can't see the amount going in? So that's what's neat about Act 1, is now students are thinking, oh, how much money is in there? What coins did he put in? It's a great chance for our students to engage in some curiosity. And we know curiosity leads to wanting to solve something. So now he concluded the end of that, and I'll pull that back up, with $1 in there. So you have to figure out how many coins or what coins did he put in. Act 2, you're given a little bit more information about the types of coins in the bank. So there's a picture right here where we can see what coins were put in the bank. Act 2 also provides the amount of, there's 12 coins in the bank, so students now can start to think a little bit more about what potential coins went in there. And then Act 3 is the reveal. After Act 2, you're spending time solving it, students are taking what they know. Act 3 is the video reveal. And students are looking at their screen, seeing if they're right, watching the video to see what coins went in, and if I fast forward to the end, it shows essentially the amount of all the coins that went in there, and you can click and it'll show an exact picture of the coins that he put in the bank. So it's a neat chance for our students to really solve a problem and then visually see what the answer is. Fruit nut bar, I'm not going to click through it, but again, it's broken up into 3 acts, a little bit of information at the beginning, a visual, a little bit more providing the actual fruit nut bar, and then Act 3 is a breakdown of what we're trying to solve in this problem. And then my other example, final lap, is a grade 5 task. NASCAR, we have a lot of students that watch NASCAR that have been to a NASCAR maybe event or have heard of it or just like cars in general. So this is a task where those students can relate with. And as you can see, it's all broken up into videos, pictures, and it's not reading based. I've attached some resources. I'm not going to click through here. The first one is really K-5 driven. The last 2 are for upper grade levels, and the third one is just a professionally written document from Solvus, and it is a breakdown of the value of 3-act tasks, why we do them, ways to use them, and it is I read it. I thought it was really neat research and just kind of backing and supporting what we're doing and our vision for engagement. So when time permits, feel free to review those resources. And the last one I just want to bring to your attention, math practice standards. And really this is, you're going to find it written as math practice standards, but really it should be standards for mathematical practice. And we know as teachers we have content standards, things we're supposed to provide. We look at what we're supposed to teach our students. And this is a great document for what for how our students should be engaged in the classroom. So really there's 8 practice standards, and this is what our students should be doing. This is what we want them to be doing throughout math problems. And you might not be able to facilitate this for every single problem, but having this idea of 8 really strong standards for what math practice should look like is important. And as you can see, I wrote for professionals and kids. So the first one on the left is broken up for professionals, and the second one on the right is broken up for what we want our kids to say in kid-friendly language. So make sense of problems and persevere them in solving them. Essentially, to a kid, what that means is I never give up on a problem and I do my best to get it right. We want to make sure we're building this understanding and this mindset with our students. 2, reason abstractly and quantitatively. I can solve problems in more than one way. And that just means when I'm given a problem, I can think about it. It's not just one definitive answer. There's more than one way to work through it. We want kids to have that understanding. Construct viable arguments, critique the reasoning of others. This means I can share my math thinking out loud, and I can talk about it, and I can defend my work, and I can talk to you about why your work is wrong. This is a really high-level thinking concept and something you should be facilitating daily. Model with math. This means I see math in every day, and I can use it to help solve problems. It's pictures, it's diagrams, it's taking math and it's showing it visually. Really important for our students that are conceptual, that struggle with maybe a little bit more of the conceptual understanding. The fifth one is use appropriate tools strategically. So I know how to choose and use the right tools to solve a problem. We're given all kinds of tools. Do we know what ones to pick from? 6, attend to precision. Am I careful with my work? Am I accurate? If I'm filling in a bar graph, am I stopping an exact line, or am I going a little bit before? In math, we have to be precise, because if we weren't precise, how could we build anything? How could we put together cars? I mean, math is all about precision. Look for and make use of structure. That just means I know how to read a problem, understand how it's created, and I use what I know to solve it. And then 8, look for and express regularity and repeated reasoning. So understanding that there's rules and patterns, and this math problem may be similar to another math problem. So using that understanding to solve anything is very important. So take this information, and hopefully you can use it when you are planning and preparing for some information or for some lessons in the next coming week or after break. I'm excited because this is just the first half of it. So we're going to do a 3-act task together when we have our chance for our meeting. But this back half of it was just some food for thought and things that good mathematicians and good math teachers are thinking about, and they're cognizant of as they are planning and having conversations with students. So enjoy, digest it a little bit, and then we'll have a chance to talk about it and reflect a little bit more.